Hello everyone, welcome back to our third video in the module on climate change and sustainability. I am Harini Nagendra and with me is PS Narayan. So in this video we are going to go deeper into the issues of where do we find solutions for climate change and how do we implement them, right? So while we do that, I think first we need to maybe recap something we talked about in our last lecture, which is what are the 3 or 4 main causes or main drivers of climate change.
Yes. So if you recollect the 3 big drivers of human-induced climate change, the first one was the burning of fossil fuels for our energy, transportation and heat needs. The burning of fossil fuels releases greenhouse gases into the atmosphere, therefore increasing the global warming effect. The second big driver is deforestation on a large scale, which removes the absorbing capacity of the forests to absorb carbon dioxide and other greenhouse gases. And third is the effect of industrial agriculture. The growing of crops like rice results in large-scale emissions of methane into the atmosphere, and as we know, methane is a very potent greenhouse gas. So if you have to look for solutions around climate change, you have to look at these 3 big causes primarily to begin with.
So let's look at the first of these big causes of human-induced climate change, right? Which is the issue of fossil fuel burning. And one of the big solutions that has been much in the news is renewable energies. India also has very ambitious targets for renewable energy, right?
Yes. And so I think this whole landscape of renewable energy and clean energy, the good thing is that we've seen an upsurge in the last few years in the production and installation of renewable energy. For example, in India, over the period 2002 to 2015, our total renewable energy base, installed base, has grown 14-fold. And there are similar, if not better, trends globally as far as renewable energy is concerned. So that's very encouraging. Let's take another example, that of transportation. In the personal transportation sector, for example, the number of electric vehicles on the road have been slowly but steadily increasing over the last few years. One estimate says that by the year 2040, 35% of all new light commercial vehicles will be electric vehicles, which will have a significant impact on the reduction of greenhouse gases into the atmosphere. That is one. Now, conservation activists and experts in sustainability around the world are pressuring governments, are pressuring policy bodies to take action on reducing deforestation at a much faster basis, to find more sustainable solutions for growing food, and to ask industry to improve their rates of resource efficiency.
So many of the challenges with finding solutions for climate change are technological in nature.
Absolutely. As things stand, there are many such technological challenges that we need to overcome. For example, in clean energy, there is this problem of intermittency. What do we mean by that? Example of solar energy. If you take that, the sun doesn't shine all 24 hours. Or if you take wind energy, the wind doesn't blow all the time or at the same speed all the time. So there are periods when you have electricity being generated. There are periods when no electricity is generated. There are periods when less electricity is generated. So there's a lot of variability. So one of the challenges in clean energy is to sort of smoothen this out by deploying storage batteries or storage technologies that can store excess power when the wind is blowing too hard or when the sun is shining strongly, and that rewheel that back, or basically reuse that extra energy when the sun doesn't shine strong enough. The challenge, technologically speaking, here is that the batteries that are required to store that much amount of energy today are very bulky, and therefore it's not practical to deploy that at a large scale. So a good technological solution will be to how do we have storage batteries that are small in size but that can store huge amounts of energy. While these technological challenges remain, The good part is there have been lots and lots of studies done on how to get there, how to be fossil fuel free. Some scholars have produced a detailed report for 139 countries of how to be 100% fossil fuel free. And if you look at this chart, it shows for India, how do we get to that 100% renewable energy status? At the top half of the chart, you will see that there is a mix of renewable energy technologies that will come into play and that will contribute to 100% renewable energy. But what's more interesting, if you look at the second half of the chart, the bottom half, is that not only will this be environmentally much better and sustainable, it will also help in the creation of 3.6 million new jobs. And these jobs are solid jobs. These are what are called 40-year jobs, which means the number of jobs where a person is employed for 40 consecutive years. So it really means a structural change in the job sector. And the second big environmental benefit of reaching this kind of scenario is that at a collective level, you will need 43% less energy, which is what the bottom half of the chart shows.
And that 43% reduction in total overall energy consumption is largely because of the fact that these technologies get more energy efficient over time, right?
Right.
But this brings us to another interesting discussion and relates to our previous discussion on the 3 Fs, because most of these technology fixes for climate change are focused on addressing challenges of finitude, and they don't really look at aspects of fairness. Either they ignore them completely or don't look at them in the detail that they should. So we discussed, for instance, in the module on the 3 Fs, how there are also challenges with, for instance, wind energy and solar energy, large scale, maybe land acquisition or other kinds of problems that actually lead to outcomes of unfairness in certain contexts. But even where they don't lead to these challenges, or you can argue that these challenges are balanced by the fact that maybe you have less coal plants or other kinds of reduction in fairness problems elsewhere, you still have the issue that there is climate change outcomes relate to a deep issue of inequity, right, between some sectors of society and other sectors of society. So how do we really propose solutions to address the issue of fairness in climate change?
Yes, and as you rightly said, that's an angle that's probably not talked enough. It is a critical element of the discussions on climate change. And we'll see a very interesting chart that illustrates this. What you see in this chart is Human Development Index versus energy axis. So let me explain that. The x-axis shows energy axis in terms of gigajoules, which is a unit of energy consumed per capita in a particular year. So annual energy consumption per capita. And the y-axis shows the Human Development Index, or HDI. What is HDI? HDI combines 3 elements of human well-being. One is the economic part, which is GDP per capita. Second is access to education, because education has a huge force multiplier effect on development. And third is access to healthcare, which is again one of the primary determinants of human well-being. And if you look at this chart, what you see is on the left-hand side, there is a very clear correlation between increase in energy consumption per capita and HDI. The more energy you consume, the sharper the increase in HDI. However, at a particular point, it starts slowing down, and then after a particular point, it actually tapers off. And that point is the range of 80 to 100 gigajoules. So in summary, what we are saying is when a country is in the early stages of its economic growth, HDI improves sharply with energy access. But beyond that band of 80 to 100 gigajoules, there is actually marginal or little improvement in HDI outcomes. You see, however, that there are several countries, developed countries, which have energy consumption levels far in excess of this limit. The United States, for example, has a 350 gigajoule per capita energy consumption level, which is 3.5 times what is really needed for, those three primary determinants of human well-being. This is a startling insight. What the chart suggests clearly is that it may be possible, perhaps, to meet all the energy needs of the world just by redistributing excess energy consumption required for luxury lifestyles to meet the basic human development needs of more than 1.2 billion people in the world today who still do not have access to energy.
So that chart is very interesting because it drives home a point that we discussed when we talked about population and consumption. Because what is this excess use of energy? This doesn't relate to the population of that country because this is per capita or per person, right? This really relates to the fact that there is more affluence in certain countries, and therefore the consumption and use of energy is much higher than it probably needs to be. And this, I think this one chart drives home that point in a very, very direct way, right?
Yes. Having said that, however, changing the course of our future developmental path is going to be easier said than done, because a lot of these problems are not technological, but they are really intricately linked to the underlying political economy and the social structure.
And this entire complex of political, of economic, of social, of environmental causes and challenges towards approaching, finding solutions for climate change is exactly why climate change is often characterized as what they call a wicked problem. It's a problem which is a system level problem where there are too many forces that act together, and you can't just tackle, there's no simple magic silver bullet, no simple technological fix, because it also involves changes in our mindset, in the way we think, in the way we approach resources, in the way we behave at a larger collective level. And this is also why climate change is often called a problem of the global commons, right? Because it requires action not just at individual levels, not just at community levels, not just at government levels, but actually across all of these levels together, right? So in the next video, we'll look further at one of these types of action to deal with global climate change at the level of nations. How are nations dealing with this problem of coming together, of negotiating, of trying to figure out what to do and how to address this? But before we get to that next lecture, Narayan, would you summarize for the audience what we've discussed today?
Yes. So in this module, we looked at solutions to climate change, solutions from all angles. The first thing we said is that energy, land use change, industrial agriculture, and transport are the biggest contributors to greenhouse gas emissions causing global warming. While many solutions require a technological in nature, they also require changes in the underlying political economy and social structures. That is point 2. Climate change is characterized as a wicked problem, and addressing it will require that we engage with its inherent messy complexity. Mere technological fixes will not work. And the third important point is related to the previous point. We cannot ignore the fact that overconsumption or affluence consumption does not result in more well-being. We saw that energy consumption beyond a certain level does not contribute to significant improvements in the Human Development Index. What this suggests is that we may be able to restrict our excessive energy use without compromising the quality of life in developed countries, and in all countries for that matter, and simultaneously improve these parameters in countries that are relatively speaking at the bottom of the ladder.
Thanks, Narayan, and any parting words for our audience?
Thank you. Yes, so I would like you to do an experiment in your own life, drawn from the illustration that we discussed on energy use versus quality of life. So what you need to do is look at the electricity consumption in your house. Look at the electricity bills of the last 3 months, arrive at an average. You can derive a per capita from that based on how many family members are there. Third, list all the uses of energy in your house. Refrigeration, air conditioning, fans, geysers, light bulbs, whatever you have. Then think through carefully and list down all possibilities where you can reduce your energy use without in any way compromising on the quality of life that you're used to. Is that possible? That's a thought experiment, so you have to think carefully. For example, you might be leaving the geyser on for 20 minutes or half an hour. It might be possible to keep it switched on just for 15 minutes and still get the same comfort that you are looking for. So there could be other examples. So go back and look at your energy consumption and come back and tell us as to how can you reduce your energy consumption in your personal lives without you having to feel in any way unsatisfied about it.
As always, we look forward to your responses in the discussion forum and to talking with you about what you think and learning from each other. Thanks Narayan again, and bye everyone. We'll see you again in the next lecture on in this as part of this module on climate change and sustainability, where we'll talk about the international arena. How have nations discussed and worked towards finding solutions for climate change? Bye.
Thank you.